Assalamualaikum and very good day to the panel and everyone. My name is Syed Muhammad Ikram bin Syed Idrus and I will presenting my final year project on the title Verification of CFD Analysis of Gas Flow Through Small Tubes. I conducted this project under the supervision of Dr. Ahmad Hussein bin Abdul Hamid. Start with the background. In general, everyone knows piping system. We can see piping system from the simplest at home to the most complex as industry. While focusing on the complex system and gas piping, we rarely discuss the medical gas system at hospital. Oxygen, nitrogen and carbon dioxide are used at the hospital. Those hospital-specific systems exist. Design a hospital system should meet all application needs. Providing an inefficient system will harm patient health. While discussing piping system in hospital, there is a specific standard that used. In Malaysia, specific for government project, Health Technical Memoranda HTM standard is the main reference used. One of the HTM standard used is HTM 0201. In the standard, it provides various of information in designing a piping system. As an example, this figure is one of the information provided in the standard as a guide in designing. It can see that the required terminal unit of a specific room has been provided. Then, in this figure show the required number of terminal which is dependent on number of bed. Furthermore, in this figure, it shows the information regarding to the pressure and flow rate desired for particular gas in specific location or room. With all the information given, it is necessary to design a system that considers all of those factors. The pressure drop of a certain length of pipe is a crucial thing that needs to be managed in order to gain the desired flow rate. Besides, the work become easier as the HTM 0201 has provided a set of data which is Appendix G that can be used as reference to design a system with an acceptable pressure drop. Next, problem statement. As we know, piping system design requires a standard. Various standards propose different design requirements. Since the HTM standard is a relevant standard that used as a reference in designing piping system, and there is lack of information regarding the theories behind the standard, it is needed to study the standard, specifically Appendix G from HTM 0201, and verify the data with CFD analysis and theoretical data. In addition, there are lack of research and verification of CFD done to observe pressure drop for medical gas flow in pipe. In the literature review, there are various of research papers referred, which related to the pressure drop. Among the studies that review are pressure drop of air-water flow in annular helicoidal pipe, the roughness effect of fluid flow in mini channel, and pressure drop of natural gas flow in pipe. In those research, the author studied about the single and two-phase flow, and several factors that affect the flow in pipe, which is Reynolds number, surface roughness, and liquid hookup. For the CFD verification, there are various of published papers that related to CFD analysis on flow in pipe. The research done using OpenFOAM software are selected to be reviewed. Among of those papers selected are discussed about gas flow in microchannel, air water flow in a pipe, and gas liquid flow in pipeline. There are several things that focus by author, which is machine determination and process, solver that's suitable, tabular model use, and visualization. Example of solver discussed in those papers are volume of fluid VOF and direct simulation Monte Carlo DSMC. There are three tabular models discussed, which is K epsilon, K omega, and shear stress transport SST. Next is methodology. The theoretical empirical analysis and CFD analysis being focused because the result will be used for the comparative analysis. After the comparative analysis is done, the next process will be continued with the program development. In theoretical empirical analysis, there are several theories related is reviewed. Those theories are Hagen-Poisson, Darcy-Weber, Colebrook, and Harlan. All these theories stated is related to study of pressure drop. In addition, Colebrook and Harlan is an equation for finding friction factor, which is friction factor is one of the parameters needed in solving Darcy-Weber equation. For Hagen-Poiseuille, it is actually similar with the Darcy-Weber with the implementation of laminar friction factor. Since the project study the laminar and turbulent flow, all of those theories are relevant to be applied in theoretical empirical analysis. For CFD analysis, there is 3 phases involved, which are pre-processing, solving, and post-processing. Firstly, in the pre-processing phase, machine development is done. Next is solving, which is pimple foam is selected rather than simple foam. Pimple foam is selected due to its ability to solve complicated equation, and tubular model selected is K epsilon. Lastly, post-processing, which is visualization, is done. ParaView software is used in the visualization process as the software can analyze large data, and it's also an open source and cross-platform software. Comparative analysis. This is performed to observe, discuss, and conclude the value between HTM-0201 with the theoretical, empirical, and CFD result. The trend of graph plotted also being compared. The target is to gain the result that identical to the HTM-0201. For the program development, it is decided to use the Microsoft Excel to develop a program that can decide the required pump power for a specific pump design. All the data from HTM-0201 will be bring into the program, as program is based on the HTM standard. Next is preliminary result. Based on the parameter available in HTM-0201, which are pressure drop, pipe diameter, flow rate, and pipe length, a calculation is done to find the required flow rate for the pressure drop of 7 kPa, 14 kPa, and 21 kPa using the Hagen-Poiseuille equation. The calculation is done for 3 different sizes of pipe, which is 12 mm, 15 mm, and 22 mm, and the length of pipe used is 15 mm. Then the graph of flow rate versus pressure drop are plotted and compared with the HTM-0201. From this graph, it is clear that the correlation between Hagen-Poiseuille and HTM-0201 is insignificant. Furthermore, it is known that Hagen-Poiseuille equation that was developed for steady-state laminar flow. Therefore, an equation that considered turbulent flow is required to be applied. The required flow rate Q is calculated using equation available in another HTM standard, which is from HTM-2022. Then the result is plotted and compared with the HTM-0201. As referred to the graph, the HTM-2022 formula gives a value that comparable with the data from HTM-0201. It has been concluded that the difference in value is due to a lack of determination of gas involved. Since the properties of gas vary, it would affect the value calculated. The HTM-2022 formula will be a guide in further study in analytical analysis. The Darcy-Weber and Harlan equation is used to calculate pressure drop for a specified case. Afterward, the graph of pressure drop against flow rate is plotted and then compared to the data from HTM-0201, and also value calculated using Hagen-Poiseuille and the HTM-2022 pressure drop equation. According to the graph, the result of both Darcy-Weber and Hagen-Poiseuille show an identical trend compared to the data from HTM-0201. After that, a CFD verification is performed to validate the data from HTM and the analytical calculation, which is calculation using Darcy-Weber with that CFD result. A case has been set with the parameter in the table. Then the verification is done using OpenFOAM software for 2 types of flow, which is laminar and turbulent flow, using an incompressible solver. The result is tabulated in the table. From the table, The result shows that the CFD turbulent analysis has a significant value with the Darcy Webeck, but not with the HTM0201 and HTM2022. Besides, the CFD laminar analysis gives a value that is analytical either with Darcy Webeck, HTM0201 or HTM2022. Since the analytical and CFD analysis of incompressible laminar and turbulent flow did not give any significant value with HTM0201 and HTM2022, it is necessary to continue further research to gain the desired value. In addition, it is also required to consider the compressible flow in further study. That's all from me. Thank you.